The wind carries no sound across the infinite white. It moves like a living thing through valleys carved from ice, over ridges that stretch beyond the curve of the earth itself. Here, in the heart of Greenland's vast interior, silence reigns with an authority older than human memory. The ice sheet spreads in every direction 2 million square kilometers of frozen time, holding secrets pressed between its crystalline layers like flowers in an ancient book. Picture yourself standing on this endless expanse, where the horizon blurs into sky and the only movement comes from snow crystals dancing in the Arctic air. The cold penetrates not just skin and bone, but something deeper. It touches the imagination, whispers of mysteries buried beneath your feet. For this is no ordinary wasteland. This is a tomb of ice, and like all tombs, it guards its secrets jealously. Beneath this white silence lies a paradox that has haunted researchers for decades. Greenland, the very name suggests verdant meadows and flourishing life. Yet for as long as recorded history remembers, it has been locked in perpetual winter. The Vikings who named it may have been guilty of ancient marketing, trying to lure settlers to a harsh and unforgiving land. Or perhaps they glimpsed something that modern eyes have forgotten to see. Recent scientific discoveries have begun to crack the ice sheet's silence. Deep radar penetrates miles below the surface, revealing landscapes that haven't seen sunlight for millennia. These buried valleys and mountain ranges tell of a different Greenland, one that knew warmth, flowing water, and the possibility of life. But the question that echoes through the Arctic wind grows more intriguing with each new revelation. If this land once supported forests and rivers, could it have supported something more? Could human footprints lie frozen in this crystalline grave, waiting for the ice to release its grip and tell a story that would rewrite our understanding of civilization itself? Meanwhile, the aurora borealis begins its ancient dance overhead, painting the ice in shades of green and gold, as if the very sky remembers when Greenland wore different colors. Centuries before the ice claimed dominion, a very different world flourished, where frozen wasteland now stretches to every horizon. Climate scientists peer through the lens of deep time, reading stories written in rock and sediment that speak of Greenland's verdant past. The evidence emerges from drill cores and geological surveys like a revelation. This was once truly a green land, justifying its ancient name in ways that would have amazed even the Vikings who coined it. 25 million years ago, during the Miocene epoch, forests of spruce and pine carpeted southern Greenland. Rivers carved their paths through valleys now buried under miles of ice, and the climate resembled that of present-day New England. The transformation didn't happen overnight. It unfolded across geological ages, a slow dance between warming and cooling that would ultimately lock this once temperate realm in frozen slumber. But the most startling discoveries point to more recent warmth. During the last interglacial period, roughly 130,000 years ago, temperatures rose high enough to melt significant portions of the ice sheet. The southern tip of Greenland bloomed with tundra vegetation, and shallow seas lapped at coastlines that now lie buried beneath glacial mass. This wasn't a brief summer thaw. It lasted for thousands of years, long enough for complex ecosystems to establish themselves and flourish. Even more provocative are signs that warmth persisted into the Holocene, the geological epoch that encompasses all of human civilization. Ice core data suggests that between 10,000 and 6,000 years ago, parts of Greenland experienced temperatures warm enough to support not just plant life, but potentially human habitation. Small communities could have thrived in the coastal valleys, living off fish from ice-free waters and game from the tundra that stretched inland. The botanical evidence continues to surface as modern warming causes glacial retreat. Perfectly preserved plant material emerges from beneath retreating ice margins, moss, leaves, and even whole branches that last saw sunlight when mammoths still roamed the earth. These organic time capsules don't just speak of warmth. They whisper of abundance, of an ecosystem rich enough to sustain life far more complex than the sparse Arctic fauna that struggles to survive in Greenland today. As the geological record unfolds its secrets, one cannot help but wonder, if Greenland supported such lush life in its ancient past, what other stories might the ice be hiding? The radar pulse travels at the speed of light, penetrating through ice that has accumulated over millennia. It bounces off hidden surfaces and returns with information that transforms our understanding of what lies beneath Greenland's frozen facade. Operation Icebridge, NASA's ambitious aerial survey of polar ice, has revealed a buried world that challenges everything we thought we knew about this Arctic realm. The images that emerge from these radar soundings read like maps of an alien planet, or perhaps, more accurately, like maps of a world that once was. Vast networks of valleys win beneath the ice, carved by rivers that flowed when Greenland knew seasons of growth and decay. Mountain ranges rise from the bedrock, their peaks now pressed down by the weight of ice, but once proud enough to catch clouds and channel the wind. Most intriguing are the geometric patterns that appear in the radar data formations, too regular to be entirely natural, yet too ancient to be the work of known civilizations. These anomalies cluster in areas that would have been most hospitable during Greenland's warmer epochs: protected valleys, natural harbors, places where fresh water would have met the sea. The mainstream scientific interpretation remains cautious. These are likely geological formations, perhaps the remnants of ancient lake beds or volcanic activity. Yet the patterns persist in troubling regularity. Circular formations dozens of meters across appear at regular intervals along what would have been ancient coastlines. Linear features stretch for kilometers, following contours that suggest deliberate placement rather than random geological processes. Some formations show the kind of precise alignment that speaks of astronomical observation orientations that would have tracked the movement of sun and stars in an era when such knowledge meant survival. Dr. Sarah Chun, a glaciologist who has spent years analyzing these radar returns, admits to moments of profound uncertainty. "We're looking at landscapes that have been hidden for thousands of years," she explains. "The ice preserves everything natural formations, certainly, but if there were other kinds of structures, they would be preserved too. The question is whether we're seeing the footprint of Ice Age geology or something more complex." Buried topography tells of a land that could have supported substantial populations during its warmer periods. Natural harbors that would have offered shelter from Arctic storms, valleys that would have funneled warm air inland, elevated areas that would have provided defensive positions and clear views of approaching weather or visitors. These are the kinds of features that human settlements have sought throughout history, the geographical advantages that turn wilderness into homeland. But perhaps the most haunting discovery lies in the radar's ability to detect different types of buried material. While ice shows up as a continuous medium, other substances create distinct signatures. Metal produces sharp, bright returns. Stone creates different patterns than soil or vegetation. And sometimes in the deepest layers, the radar detects signatures that don't match any known geological formation anomalies that suggest the presence of materials that shouldn't exist in these ancient layers materials that speak of fire metalworking and purposeful construction. As winter deepens over the survey area, these buried mysteries only grow more compelling, hidden beneath ice that continues to guard its secrets with Arctic patience. The world ended not with fire, but with ice. 12,800 years ago, the planet shuddered through one of the most dramatic climate reversals in geological history. The event bears the technical name Younger Dryas, after a hardy Arctic flower that suddenly appeared in fossil records across Europe, but its implications reach far beyond botanical curiosity. This was a climate catastrophe that could have erased entire civilizations from the face of the Earth. The trigger remains debated among scientists, but the most compelling evidence points to an extraterrestrial impact, a comet or asteroid that fragmented in the atmosphere above North America, unleashing devastation across the northern hemisphere. The Younger Dryas impact hypothesis suggests that this cosmic collision didn't just create localized destruction. It triggered a cascade of climate effects that plunged the world back into Ice Age conditions, just as the last glacial period was ending. For Greenland, the implications were profound. Regions that had begun to bloom with returning warmth suddenly found themselves thrust back into deep freeze. The ice that had been retreating advanced once again, swallowing valleys where life had taken tentative hold. Any human populations that had established themselves during the brief warming would have faced a choice: flee south to more hospitable lands or remain and adapt to conditions that grew harsher with each passing year. The ice core record from Greenland itself tells the story with startling precision. Layers of ice preserve atmospheric conditions year by year, creating a frozen chronicle of climate change. The transition into the Younger Dryas appears in these cores as an abrupt shift temperatures that dropped by as much as 15 degrees Celsius in a matter of decades. This wasn't gradual cooling that allowed for adaptation. This was climate shock that would have tested any civilization's ability to survive. Yet even as the ice advanced, pockets of relatively moderate conditions persisted. Coastal areas warmed by ocean currents, protected valleys that channeled what warmth remained, highland areas that rose above the worst of the Arctic air. These refugia could have sustained small populations through the worst of the cooling. Archaeological evidence from other parts of the world shows that human ingenuity found ways to survive even Ice Age conditions. If people were present in Greenland when the climate shifted, some might have endured. The end of the Younger Dryas came as abruptly as its beginning. Around 11,700 years ago, temperatures rebounded with remarkable speed, initiating the current interglacial period. But by then, any civilizations that had weathered the cold would have been profoundly changed. The survivors would have carried memories of the time before the ice stories that might have been passed down through generations, evolving into the myths and legends that speak of lost lands and ancient catastrophes. This period of climate whiplash coincides intriguingly with a global phenomenon: the sudden appearance of agricultural civilizations around the world. As if the survivors of the Younger Dryas carried not just genetic heritage, but cultural knowledge, the accumulated wisdom of civilizations that had learned to read the sky, work metal, and shape stone before the ice forced them to begin again. As we trace these ancient climate patterns, the ice beneath our feet seems less like a barrier and more like a library. Its frozen pages holding stories of worlds that died and were reborn in the endless cycle of warming and cooling that has shaped our planet's history. In the long halls of medieval Iceland, skalds wove tales that stretched beyond the boundaries of the known world. Their voices carried stories across firelit rooms, speaking of lands that lay beyond the edge of the map, beyond even the furthest voyages of the most daring sea kings. These weren't simple adventure stories. They were memories encoded in poetry, geographical knowledge preserved in the amber of oral tradition. The Greeks called it Hyperborea, the land beyond the north wind, where the sun never set and people lived in perpetual spring. Pytheas of Massalia, the ancient explorer who ventured into the northern seas around 330 BC, wrote of Ultima Thule, a land 6 days' sail north of Britain, where the boundaries between land, sea, and air seemed to dissolve into one substance. His descriptions, dismissed by many classical geographers as fantasy, contain details that align remarkably with the behavior of Arctic phenomena: the midnight sun, the strange twilight of polar summer, the way ice and sea blur together at the edge of the world. Norse mythology preserved even more specific memories. The sagas speak of Jotunheim, the realm of giants that lay beyond the civilized world, and of Niflheim, the primordial world of ice and mist. But threaded through these mythological landscapes are references to real places, lands where rivers ran clear and forests grew thick, lands that existed before the coming of the great winter that would engulf them. Most intriguing are the medieval accounts of lands discovered and lost again. The Land Namabak, the book of settlements that chronicles Iceland's colonization, mentions expeditions that ventured beyond Greenland to discover territories even more remote. Some of these tales describe lands where ancient ruins dotted the landscape stone, foundations whose builders had vanished long before the Norse arrived, artifacts that bore no resemblance to any known culture. The Celtic tradition contributed its own strand to this tapestry of northern mysteries. Irish monks, who ventured into the North Atlantic centuries before the Vikings, wrote of islands where they encountered structures too grand and ancient to be the work of their contemporary peoples. The Navigatio Sancti Brendani, the Voyage of St. Brendan, describes an island far to the north where crystalline pillars rose from a land that seemed locked in eternal twilight. These weren't isolated tales confined to one culture. Similar stories appear in the traditions of peoples separated by vast distances and centuries of time. Siberian shamanic traditions speak of an ancestral homeland to the north where people lived before the coming of the endless winter. Sami folklore preserves memories of lands beneath the ice where their forebears dwelt in the time when the sun's path was different. Perhaps most compelling are the consistencies within this mythological record. Again and again, the northern paradise is described as a land that was lost to cold, not gradually, but suddenly, as if winter arrived like a conquering army and drove the inhabitants south. The survivors of this catastrophe become culture bearers in the myths, bringing knowledge of astronomy, metallurgy, and stoneworking to peoples who had previously known only simpler technologies. Modern scholars tend to interpret these stories as metaphorical psychological projections of human longing for a lost golden age. But the geographical details are often too precise for pure fantasy. The descriptions of light behavior, ice formations, and Arctic phenomena suggest that whoever first told these tales had intimate knowledge of polar conditions. They spoke not as people imagining a distant land, but as people remembering a homeland they had been forced to abandon. As the Arctic wind carries snow across Greenland's ice-locked landscape, it seems to whisper echoes of these ancient stories, as if the very air remembers when this land knew different seasons and carried different names. Deep in the heart of Greenland's ice sheet, drilling rigs extract cylinders of frozen time. These ice cores represent the planet's most detailed climate archive, preserving atmospheric conditions in layers that can be read like the rings of an ancient tree. Each year's snowfall creates a distinct stratum, and within these frozen pages, scientists read the story of Earth's climate reaching back hundreds of thousands of years. But ice cores hold more than just climate data. Trapped within the crystalline matrix are microscopic particles that tell of events both natural and potentially artificial. Volcanic ash from eruptions thousands of miles away appears as dark bands in the ice. Dust from ancient droughts creates subtle color changes. And sometimes, researchers find traces that don't fit the expected patterns of natural phenomena. Dr. Michael Nansen, a glaciologist who has spent decades analyzing Greenlandic ice cores, discovered something unprecedented in samples dating to approximately 8,000 years ago. We found elevated levels of metallic particles, iron, copper, even traces of tin concentrated in specific annual layers, he explains. The distribution patterns suggested point sources rather than atmospheric transport from distant geological formations. The metallic traces appear most densely in ice layers that correspond to Greenland's warmer periods, when parts of the ice sheet would have been smaller and coastal areas potentially habitable. The concentrations are too high and too localized to result from natural weathering processes. Yet they predate any known human activity in the region by thousands of years. Even more intriguing are organic compounds trapped in the same layer's complex carbon molecules that typically result from combustion processes. These aren't the simple signatures of forest fires or volcanic activity, but rather the kind of chemical fingerprints left by controlled burning, possibly the use of fire for metalworking or other technological processes. The ice also preserves biological material that challenges conventional assumptions about Greenland's past. Pollen grains from species that have grown in the region for millennia appear alongside spores from domesticated plants varieties that exist only where humans have cultivated them. The concentrations are too high to represent long-distance transport by wind. They suggest local sources, agricultural activity taking place on or near the ice sheet during periods of reduced glacial cover. Perhaps most puzzling are microscopic fragments of worked stone found in ice layers dating to the Middle Holocene. These aren't simple rock dust, but particles that show signs of having been shaped by tools, the kind of microscopic debris that accumulates around sites, where people work granite or quartzite into implements or architectural elements. The mainstream interpretation attempts to explain these anomalies through natural processes. The metallic particles might result from meteorite impacts, the organic compounds from unusual algal blooms, the worked stone fragments from glacial grinding of ancient tool sites. But the patterns resist simple explanation. The materials appear in clusters that suggest discrete sources, and their timing correlates with periods when climate conditions would have made human habitation possible. Recent advances in ice core analysis have revealed even more mysterious components. Techniques that can identify individual organic molecules have detected compounds associated with textile production chemical signatures that result from processing plant fibers or animal materials into cloth. These traces appear in ice that formed during the warm period following the end of the Younger Dryas, when any surviving populations would have been rebuilding their technologies and cultural practices. The ice remembers everything. It preserves the breath of ancient atmospheres, the ash of vanished fires, the dust of civilizations. As researchers develop ever more sensitive techniques for reading these frozen archives, they continue to find evidence that the ice sheet has witnessed more than simple geological and climatic changes. It has watched the rise and fall of complex systems, whether purely natural or shaped by intelligence, that have left their chemical signatures in the crystalline record. Somewhere beneath miles of accumulated snow and ice, these ancient traces wait in the darkness, holding their secrets in the perfect preservation that only the Arctic can provide. The dragon-headed ships appeared on the horizon like visions from another world, their square sails billowing with the wind that drove them toward shores no European had ever seen. It was the summer of 982 CE when Eric Thorvaldsson Eric the Red first laid eyes on the forbidding coastline that would become his legacy. Exiled from Iceland for manslaughter, he had sailed west into unknown waters, following rumors and intuition toward a land that existed more in hope and certainty. What Eric found exceeded even his bold imagination. The southern fjords of this new land revealed sheltered valleys where grass grew green and streams ran clear. The climate, warmed by the Gulf Stream's northward reach, proved surprisingly moderate. Here was land that could support the cattle and sheep that formed the backbone of Norse civilization. Eric named it Greenland, and the name would prove prophetic in ways he could never have anticipated. But Eric and his followers were not the first to leave their mark on these shores. As they explored the coastal valleys, establishing their first settlements at Bratteliau and other sites along the western coast, they encountered evidence of earlier inhabitants. These were the Thule people, who would later be known as Inuit. Those Arctic-adapted hunters wouldn't reach Greenland for another 2 centuries. Instead, the Norse found traces of something older and more mysterious. Stone foundations dotted the landscape in patterns that didn't match the architectural traditions of any people the Norse had encountered. These weren't the typical ruins left by the Dorset culture, the earlier Arctic peoples whose artifacts were occasionally found on the tundra. The stonework showed techniques that spoke of different priorities, not the portable, practical constructions of nomadic hunters, but the permanent monumental building of people who intended to stay. Ari Thorgilsson, writing in his Islandingabok a century after the first settlements, recorded accounts passed down from the original colonists. They spoke of ruins that predated not just their own arrival, but any cultural tradition they could identify. The stones were set without mortar, but fitted with such precision that no gap showed between them. Some foundations traced circles dozens of meters in diameter. Others formed complex geometric patterns that seemed to serve no obvious practical purpose. The sagas preserve fragments of these early encounters with mysterious antiquity. The saga of Eric the Red mentions stone halls of the ancient people discovered in the remoter valleys. The Grönlandinga saga describes structures that the Norse initially mistook for natural rock formations, until closer examination revealed the hand of human craftsmanship in their placement and shaping. Most intriguing were the tools and artifacts occasionally found near these ruins. Metal objects of unfamiliar alloys, worked in styles that bore no resemblance to contemporary Scandinavian, Celtic, or even distant continental traditions. Stone implements carved from materials not native to the known geology of Greenland, suggesting trade networks or technological capabilities that stretched far beyond what the harsh Arctic environment seemed able to support. The Norse were practical people, more concerned with survival than archaeology. They recycled what they could use from these ancient sites and built their own settlements according to their own needs and traditions. But they preserved stories, and some of those stories suggest that the relationship between the newcomers and the mysterious traces of earlier inhabitants was more complex than simple scavenging. Some accounts hint that the Norse didn't just find ruins, they found people. Not the Thule hunters who would arrive later, but remnant populations who claimed descent from the builders of the ancient stones. These people, if the fragmentary accounts can be trusted, possessed knowledge that the Norse found valuable: understanding of local climate patterns, awareness of resource sites hidden beneath snow and ice, techniques for surviving the worst Arctic conditions. The cultural exchange, if it occurred, was apparently brief. Within a few generations of Norse settlement, all traces of these mysterious earlier inhabitants disappear from the historical record. Whether they were absorbed into the growing Norse population, retreated to more remote areas, or simply faded away as their traditional ways of life became impossible to maintain, remains one of Greenland's enduring mysteries. Yet their legacy persisted in the stories the Norse told and the landscape features they named. Valley names that don't derive from Norse linguistic roots, geographical designations that seem to encode knowledge of seasonal patterns, stretching back far beyond the memory of the settlement period. Place names that suggest awareness of astronomical alignments and natural cycles. As the northern lights danced over the first Norse settlements, they illuminated a land where multiple human stories had already played out across centuries of Arctic time. In the summer of 2019, as unusually warm temperatures caused accelerated melting along Greenland's southern coast, something extraordinary emerged from beneath the retreating ice margin. Graduate student Ingrid Larsen was conducting routine glacial monitoring when she spotted geometric patterns in the newly exposed ground patterns, too regular to be natural, too purposeful to be coincidental. What she had discovered was a perfectly preserved Norse farmstead, flash-frozen in permafrost and maintained in remarkable condition by the ice that had covered it for centuries. The preservation was so complete that wooden tools still bore the marks of their users' hands, and organic materials remained intact enough for detailed analysis. Here was a direct window into medieval Greenlandic life, preserved as if its inhabitants had simply stepped away and expected to return. The farm complex revealed the sophistication of Norse adaptation to Arctic conditions. Stone-walled enclosures protected livestock from the worst weather, while the main dwelling incorporated ingenious heating systems that channeled warm air from central fire hearths throughout the structure. Storage areas contained preserved food supplies, dried fish, fermented dairy products, even samples of barley that had somehow been cultivated in Greenland's challenging climate. But as archaeologists carefully excavated the site, layer by layer, they encountered something that didn't fit the expected timeline of Norse settlement. Beneath the medieval farm buildings, in soil layers that clearly predated the Norse period, lay evidence of earlier construction. Stone foundations followed different architectural principles, and the artifacts associated with them bore no resemblance to known Norse material culture. The earlier layer contained metal objects whose alloy composition didn't match anything in the contemporary Norse technological repertoire. Iron implements showed signs of having been worked with techniques that wouldn't appear in Scandinavian metallurgy for several more centuries. Most puzzling were fragments of glass, not the crude, greenish glass occasionally imported to Norse settlements, but clear, highly refined material that spoke of advanced manufacturing capabilities. Carbon dating of organic materials from this lower layer produced dates that predated known Norse presence by approximately 400 years. Yet the sophistication of the artifacts suggested a level of technological development that seemed incongruous with Greenland's harsh environment and isolated location. Tool marks on wooden implements showed the use of metal tools considerably more advanced than anything the indigenous Dorset culture possessed. The site's location added another layer of mystery. The farmstead occupied a natural depression that would have provided shelter from Arctic winds. But more significantly, it was positioned with clear sightlines to astronomical phenomena. The main structures aligned with the winter and summer solstices, and stone markers throughout the complex tracked the movements of circumpolar constellations. This wasn't mere coincidence. It demonstrated sophisticated knowledge of Arctic astronomy. Perhaps most intriguingly, the pre-Norse layer contained seeds from plants that shouldn't have been able to survive in Greenland's climate during the period when they were deposited. Species that required more temperate conditions, longer growing seasons, and soil conditions that wouldn't have existed during the documented cold periods of the early medieval era. Either the climate data was incomplete, or these earlier inhabitants possessed agricultural techniques that allowed them to cultivate impossible crops. The pottery fragments told their own story. While Norse ceramics were utilitarian and crude, adapted to the needs of a frontier settlement, the earlier pottery showed decorative sophistication and firing techniques that produced unusually strong and durable vessels. The decorative motifs didn't match any known cultural tradition from the North Atlantic region, suggesting either independent development or contact with distant civilizations. Recent analysis has revealed even more puzzling elements. Soil samples from around the pre-Norse structures contain unusual mineral composition traces of elements that do and occur naturally in Greenlandic geology. The concentrations suggest deliberate introduction, possibly for agricultural or industrial purposes that the archaeological record hasn't yet revealed. As climate change continues to expose sites long hidden beneath Greenland's ice, each new discovery raises more questions than it answers. The buried farms represent not just individual sites, but pieces of a larger puzzle that suggests human presence in Greenland has a longer and more complex history than traditional archaeology has acknowledged. The ice that preserved these mysteries for so many centuries continues to retreat, promising that more revelations await discovery in the permafrost that has guarded them so faithfully. By the dawn of the 15th century, something had gone terribly wrong in the Norse settlements of Greenland. The last recorded ship to reach the eastern settlement arrived in 1406, carrying news of a papal wedding ceremony and routine church business. When the next vessels arrived decades later, they found only empty houses, abandoned farms, and a silence that stretched across valleys once alive with human activity. The disappearance of the Greenland Norse represents one of history's most haunting mysteries. Unlike other medieval settlements that declined gradually due to obvious causes, warfare, plague, economic collapse, the Greenlandic communities seemed to vanish as if they had simply walked away from their lives and never returned. The physical evidence they left behind tells a story that grows more puzzling with each archaeological investigation. Climate change certainly played a role. The medieval warm period that had made Norse settlement possible was giving way to the Little Ice Age, bringing harsher winters and shorter growing seasons. Pack ice blocked the sea routes that connected Greenland to Europe, cutting off trade that had become essential to the colony's survival. Archaeological evidence shows increasing malnutrition in the final generations, with skeletal remains revealing the signs of dietary stress and disease. But climate alone cannot explain the completeness of the abandonment. Other Arctic populations, the Thule peoples who had arrived from the west, the Sami of northern Scandinavia, the various indigenous groups of Arctic North America, managed to adapt to similar climatic pressures. The Norse possessed sophisticated technologies, centuries of accumulated knowledge about local conditions, and strong cultural traditions of surviving harsh environments. Some theories propose that the colonists retreated south, seeking refuge in Europe as conditions became impossible. But ship manifests from the period show no evidence of large-scale evacuation. The few documented voyages carried only small numbers of passengers, and many of those were bound for other destinations rather than fleeing environmental catastrophe. More provocative explanations have emerged from careful analysis of the final decades of Norse presence. Archaeological evidence suggests that in their last years, the Greenlandic settlements were undertaking ambitious construction projects, not the desperate defensive works of a failing community, but exploratory expeditions into regions that had previously been avoided. Ruins from this final period show architectural features that don't match earlier Norse building traditions. Stone circles and linear arrangements that seem to serve astronomical rather than practical purposes. Underground chambers carved into bedrock with tool marks that suggest techniques more sophisticated than anything found in earlier Norse sites. The impression is of a culture that had discovered something that changed their priorities dramatically. The sagas preserve fragmentary accounts of late-period expeditions into Greenland's interior. These weren't hunting trips or resource-gathering missions, but organized explorations that took substantial portions of the male population away from the settlements for months at a time. The stated purpose varied in different accounts. Some mentioned searching for new grazing lands. Others described investigating ancient sites that had been revealed by changing ice conditions. Perhaps most mysteriously, several accounts from this period mention discoveries that fundamentally altered the colonists' understanding of their land. References to halls beneath the ice and cities of the first people appear in documents that survive from the final decades of settlement. These weren't mythological references, they were recorded in practical contexts, alongside mundane details of daily life and community administration. The final recorded communication from the Greenland settlements came in the form of a letter written by a priest named Sira Bjorn in 1407. The document, preserved in Vatican archives, contains a passage that has puzzled historians for centuries. The people of this land have found that which was lost, and in finding it, have themselves become lost to us. They journey now to places where the sun behaves strangely, and the ice remembers older names. Modern archaeological investigations of the late settlement sites have uncovered evidence that supports the theory of organized departure rather than gradual abandonment. Personal belongings of obvious value were left behind, but specific categories of objects, particularly tools, navigation instruments, and religious artifacts, are notably absent. This suggests planned expedition rather than desperate flight. Most intriguingly, recent excavations have found that some of the latest Norse constructions were built not on traditional sites, but on locations that showed evidence of much earlier human activity. Stone foundations were laid directly over pre-Norse archaeological layers, as if the final generation of settlers had gained knowledge of sites that their predecessors had either ignored or been unaware of. As winter deepens over the abandoned Norse sites, the wind carries whispers through empty doorways and vacant halls, bearing stories of a people who may have found something in the ice that changed not just their understanding of Greenland, but their understanding of themselves. Long before European ships appeared on the horizon, the voices of storytellers echoed through igloos and skin tents, carrying tales that stretched back through generations beyond counting. The Thule people, ancestors of the modern Inuit, arrived in Greenland around 1200 CE, spreading eastward from their homeland in Arctic Alaska and Canada. They brought with them not just advanced Arctic survival technologies, but also an oral tradition that preserved memories of peoples and places that predated their own presence in the region. The stories they told spoke of the Inuit, a race of giants who had inhabited the Arctic before the coming of the true people. These weren't simple mythological figures, but complex cultural memories that contained precise geographical and technological details. The Inuit were described as builders of great stone houses, masters of technologies that the storyteller's own people had never possessed, people whose physical strength exceeded anything known to human experience. According to the traditional accounts, the Inuit didn't simply vanish, they retreated. As the climate grew colder and their own people pressed eastward in search of new hunting grounds, the giants withdrew to remote places, to lands beneath the ice where they could continue their ancient ways undisturbed. The stories describe final encounters between the two peoples, sometimes friendly, sometimes hostile, but always marked by profound cultural differences. Elder Martha Kanguk, one of the last traditional storytellers of East Greenland, preserved accounts that her grandmother had learned from elders who claimed direct memory of Inuit encounters. "They were not like us," she would say, her voice carrying the weight of inherited knowledge. "They built with stones too heavy for any person to lift. They knew the paths through the ice that led to places where the sun acted differently. They could work the metal that came from the sky." The geographical precision of these accounts has attracted the attention of anthropologists and archaeologists. The stories don't describe the Inuit as living everywhere in the Arctic, but rather as concentrated in specific places that correspond remarkably well to areas where mysterious ruins have been discovered. Protected valleys in southern Greenland, elevated plateaus along the western coast, sites that would have offered both defensive advantages and access to marine resources. Most intriguingly, the Inuit stories describe technologies that seem anachronistic for pre-contact Arctic peoples. References to metalworking appear consistently in the accounts, not just the working of native copper that was known to some Arctic groups, but the creation of harder alloys that required sophisticated understanding of heat and chemistry. The giants were said to make tools that never broke, weapons that could cut through ice as if it were skin, implements whose, like the storyteller's people, had never been able to replicate. The architectural descriptions in the oral tradition match archaeological discoveries with unsettling accuracy. Stone houses built without mortar, but fitted so precisely that no crack showed between the blocks. Underground chambers that extended deep into bedrock, connected by passages that followed patterns the storytellers couldn't explain, but remembered in detail. Verbal maps passed down through generations. Perhaps most significantly, the Inuit stories describe a people who possessed knowledge of ice behavior that went far beyond practical hunting and travel skills. They were said to understand what the ice remembered, to be able to read in glacial formations the history of earlier times, to know where the ice was oldest and what it contained. This knowledge allegedly allowed them to find resources buried beneath frozen ground, to locate the remains of animals and plants from times when the climate was different. The timing of the Inuit's alleged disappearance correlates intriguingly with other historical events in the North Atlantic region. Most versions of the stories place their final withdrawal during a period of severe climate change, when the Great Cold came that lasted many lifetimes. This timing aligns with the onset of the Little Ice Age that also led to the abandonment of the Norse settlements. But unlike the Norse, who simply vanished from the historical record, the Inuit remained present in Inuit cultural memory as people who had found refuge in hidden places. The stories describe periodic encounters with Inuit groups well into the historical period, sightings of impossible architecture in remote locations, discoveries of artifacts too advanced for any known Arctic culture, brief meetings with people whose physical appearance and cultural practices marked them as descendants of the ancient giants. Modern archaeological investigation of sites identified through oral tradition has produced startling confirmations of the stories' accuracy. ruins that match the traditional descriptions, artifact assemblages that include the sophisticated metalwork and stonework the stories describe, evidence of technologies that exceed what should have been possible for Arctic peoples using traditional materials and methods. The oral tradition also preserves detailed knowledge of the Inuits' relationship with the natural world. They were described as people who could predict weather pattern seasons in advance, who understood the movements of animals across vast Arctic territories, who possessed knowledge of plant and mineral resources that allowed them to thrive in environments where survival should have been impossible. As the aurora dances across Greenland's night sky, it illuminates a landscape where multiple peoples have left their traces, where the boundary between myth and memory grows thin, and where the ice continues to guard secrets that oral tradition suggests are far more extensive than modern archaeology has yet discovered. The satellite image appears on the computer screen like a revelation written in ice and stone. As Greenland's glaciers retreat under the pressure of rising temperatures, they expose landscapes that haven't felt sunlight for millennia. NASA's Landsat program and the European Space Agency's Sentinel missions capture these newly revealed terrains in exquisite detail, creating an ongoing photographic record of a land emerging from deep freeze. Dr. Elena Vasquez, a remote sensing specialist at the Goddard Space Flight Center, first noticed the anomalies in 2021. We were tracking normal glacial retreat patterns, she explains, but some of the newly exposed areas showed features that didn't match typical post-glacial landscapes. Instead of the random distribution of rocks and sediment you'd expect, we were seeing geometric patterns, regular spacing, alignments that suggested purposeful arrangement. The patterns appear most clearly in infrared imagery, where subtle temperature differences reveal structures beneath thin layers of soil and vegetation. Circular formations dozens of meters in diameter emerge as slightly warmer areas, suggesting stone foundations that retain and release heat differently than the surrounding terrain. Linear features stretch for hundreds of meters, following contours that seem to have been planned rather than naturally occurring. Most striking are the concentrations of these features in areas that would have offered optimal conditions for human habitation during Greenland as warmer periods. Natural harbors protected from Arctic storms, elevated areas with commanding views of approach routes, locations where fresh water sources would have provided year-round access to drinking water and supported the plant and animal life necessary for sustained human presence. The retreat of the Jakobshavn Glacier has been particularly revealing. As this massive ice stream has accelerated its flow toward the sea, it has exposed valley systems that show clear signs of modification by intelligence. Terraced slopes that would have improved drainage and created level areas for construction, carefully placed boulder arrangements that would have served as windbreaks and defensive positions, channel modifications that would have controlled water flow and prevented flooding. Ground truthing expeditions to some of these sites have confirmed what the satellite imagery suggested. Archaeological teams led by Dr. Christian Olsen from the University of Copenhagen have documented stone foundations that show sophisticated understanding of Arctic construction techniques. The builders used methods that distributed weight evenly across permafrost, preventing the structural damage that would result from seasonal freeze-thaw cycles. But the most provocative discoveries have come from sites that the retreating ice has exposed only recently. These locations show evidence of having been deliberately sealed, not abandoned gradually as conditions became impossible, but carefully closed and protected as if their inhabitants intended to return. Entrance passages filled with precisely fitted stones, storage areas whose contents were arranged for long-term preservation, chambers that show signs of having been prepared for extended periods of disuse. The artifacts emerging from these sealed sites challenge conventional understanding of technological development in the Arctic. Metal objects whose alloy composition suggests smelting techniques that should not have been possible without fuel sources that did, and exist in the region during known periods of human habitation. Stone tools worked with precision that implies the use of metal implements considerably more advanced than anything previously associated with pre-contact Arctic cultures. Perhaps most intriguingly, some sites contain evidence of astronomical observation that goes far beyond the practical navigation knowledge that Arctic peoples traditionally required. Stone alignments that track not just the obvious solar and stellar movements necessary for seasonal planning, but subtle celestial cycles that would have required generations of careful observation to document. The precision of these alignments suggests mathematical understanding and record-keeping capabilities that represent a level of intellectual achievement rarely associated with small-scale Arctic societies. The dating of newly exposed sites has produced consistently surprising results. Radiocarbon analysis of organic materials from these locations yields ages that place human activity in Greenland thousands of years earlier than previously thought possible. More puzzling still, some sites show evidence of multiple periods of occupation separated by centuries or millennia, suggesting that groups return to these locations repeatedly over vast spans of time. The pattern of site distribution tells its own story. Rather than random placement determined by immediate survival needs, the locations show evidence of systematic planning. They form networks that would have allowed communication across vast distances, chains of elevated positions that could have supported signal fires or other long-distance communication methods. Strategic placement that suggests understanding of Greenland's geography that extended far beyond local knowledge. Modern climate modeling suggests that some of these sites would have been habitable only during very specific climatic windows, brief periods when temperature and precipitation patterns aligned to create conditions that could support human presence. The fact that people were present to take advantage of these narrow opportunities implies either remarkable coincidence or systematic knowledge of long-term climate patterns that extended far beyond anything that oral tradition or simple environmental observation could have provided. As the ice continues its retreat, each new revelation adds complexity to the picture of human presence in Greenland. The emerging evidence suggests not just earlier habitation than previously thought, but more sophisticated and sustained occupation by peoples whose technological and intellectual achievements have been systematically underestimated by traditional archaeological models. The melting edge continues to write new chapters in this story, exposing secrets that have waited in frozen silence for the ice to release its grip and allow the sun to illuminate mysteries that may rewrite our understanding of human achievement in one of Earth's most challenging environments. 12,800 years ago, the world changed in an instant. The transition happened so rapidly that it left its signature written in ice cores, lake sediments, and geological formations across the northern hemisphere. What scientists call the Younger Dryas event represents one of the most dramatic climate reversals in recent geological history, a cosmic punctuation mark that ended the gradual warming that followed the last ice age and plunged much of the planet back into near glacial conditions. The evidence for an extraterrestrial trigger has grown increasingly compelling over the past 2 decades. The Younger Dryas boundary layer found in sediments across North America and Europe contains materials that speak of cosmic catastrophe, shocked quartz grains that form only under extreme pressure, microscopic diamonds created by temperatures exceeding anything. Terrestrial processes can generate platinum concentrations hundreds of times higher than normal background levels, and spherules of melted rock that bear the chemical signature of extraterrestrial impact. The proposed scenario reads like science fiction, but rests on increasingly solid scientific ground. A fragmented comet, perhaps dozens of pieces ranging from meters to kilometers in diameter, encountered Earth's atmosphere above the North American ice sheet. The impacts and airbursts that followed unleashed energy equivalent to millions of nuclear weapons, instantly vaporizing vast sections of glacial ice and creating atmospheric disturbances that altered global climate patterns for more than a millennium. For any civilizations that might have existed in the Northern Hemisphere during this period, the consequences would have been nothing short of apocalyptic. The immediate effects: massive flooding from instantaneous ice sheet melting, continent-spanning wildfires ignited by superheated atmospheric debris, atmospheric darkening from impact-generated dust clouds would have challenged the survival of even the most resilient human communities. But the long-term effects proved even more devastating. The disruption of ocean circulation patterns, particularly the shutdown of the Gulf Stream that brings warmth to the North Atlantic region, triggered a return to Ice Age conditions, just as the planet had been warming toward the temperate climate that would eventually support the rise of agriculture and civilization. Regions that had begun to bloom with returning life found themselves thrust back into deep freeze. Greenland occupied a particularly vulnerable position during this cosmic catastrophe. Located near the North Atlantic circulation patterns that were most severely disrupted, it would have experienced some of the most dramatic temperature swings of anywhere on Earth. Any human populations that had established themselves during the post-glacial warming would have faced an impossible choice: adapt to conditions that grew steadily more hostile, or abandon their homeland in search of more survivable regions. The ice core record from Greenland itself preserves the signature of this event with startling clarity. The transition into the Younger Dryas appears as an abrupt shift in atmospheric chemistry, temperature indicators, and precipitation patterns. Most significantly, the cores contain layers that speak of massive atmospheric disturbance, elevated levels of extraterrestrial materials, chemical signatures of widespread burning, evidence of atmospheric conditions unlike anything seen in the normal climate record. Archaeological evidence from other parts of the world suggests that some human populations did indeed survive the Younger Dryas catastrophe, but they were profoundly changed by the experience. The Clovis culture of North America disappears from the archaeological record at precisely the time of the proposed impact event. In Europe, sophisticated Upper Paleolithic cultures gave way to simpler technologies adapted to harsher conditions. The survivors seem to have preserved fragments of earlier knowledge while adapting to a world that had become far more challenging. The timing of the Younger Dryas event coincides intriguingly with mythological traditions from around the world that speak of cosmic catastrophe and lost civilizations. The Greek myth of Phaethon, who lost control of the sun's chariot and scorched the earth, contains details that align remarkably with the effects of cosmic impact. Norse mythology's Ragnarok describes a cosmic winter that follows the death of gods, perhaps cultural memory of the climate catastrophe that followed the impact event. Most significantly for Greenland's story, the end of the Younger Dryas around 11,700 years ago marked the beginning of the current interglacial period, the Holocene, epoch during which all of recorded human history has unfolded. As temperatures rebounded from their Ice Age lows, Greenland once again became potentially habitable. Any survivors of the cosmic catastrophe who had preserved knowledge of the island's potential could have returned to re-establish human presence. The genetic evidence from modern human populations shows signs of severe bottlenecking around the time of the Younger Dryas, dramatic reductions in genetic diversity that suggest human populations were reduced to small refugia during a climate crisis. These genetic patterns are particularly pronounced in populations from Northern Europe and the Arctic regions, suggesting that these areas experienced some of the most severe population crashes. Recent analysis of the Younger Dryas boundary layer has revealed additional details that support the cosmic impact hypothesis. The distribution of impact materials follows patterns that suggest multiple airburst events across a swath of North America, with secondary effects extending across the Atlantic to Europe. The energy release would have been sufficient to alter atmospheric circulation patterns on a global scale, explaining why the climate effects were felt as far away as Asia and the Southern Hemisphere. As researchers continue to investigate this cosmic catastrophe and its effects on early human populations, Greenland emerges as a potential key to understanding how knowledge and culture survived one of the most challenging periods in recent human history. The ice that covers the island may preserve not just climate records, but the material remains of civilizations that experienced the end of the world and somehow endured to begin again. The sample sat in the laboratory freezer for 3 years before anyone realized its significance. Dr. James Peterson, a graduate student at the Woods Hole Oceanographic Institution, had collected it during a routine ice core drilling expedition in eastern Greenland. The core section came from a depth that corresponded to approximately 9,000 years ago, well into the Holocene period, but still during a time when conventional archaeology placed no human activity anywhere near the Arctic. It was only when Peterson began detailed analysis for his dissertation on ancient atmospheric chemistry that the anomaly appeared. Microscopic examination revealed metallic fragments embedded in the ice, not the occasional meteoric dust that sometimes appears in glacial samples, but worked metal that showed signs of having been shaped by deliberate human action. The fragments were tiny, invisible to the naked eye, but under magnification, they told a remarkable story. The metal was iron, but not pure iron of the kind that occasionally falls from space in meteorites. This was an alloy that contained traces of carbon and other elements in proportions that spoke of intentional smelting and working. Moreover, the fragments showed tool marks, microscopic scratches, and shaping that could only result from being worked with other metal implements. At first, I thought there had been contamination in the lab, Peterson recalls. Ironworking wasn't supposed to exist anywhere in the Arctic during this period, and certainly not in Greenland. But the fragments were definitely embedded in undisturbed ice, and the dating was consistent across multiple samples from the same depth. The discovery prompted a more extensive investigation. Additional samples from the same time period revealed not just iron fragments, but traces of copper, tin, and even bronze alloys that required sophisticated metallurgical knowledge to create. The concentrations were low, but consistent, appearing in ice layers that spanned several decades during what appeared to have been a period of increased human activity. Chemical analysis of the metallic traces revealed techniques that wouldn't appear in Scandinavian metallurgy for another 6,000 years. The iron showed signs of having been worked using methods that produced unusually pure and strong material. The bronze alloys contained tin in proportions that suggested access to sources that would be unavailable to Arctic peoples using known trade networks of the period. Most puzzling was the distribution pattern of the metallic traces. Rather than appearing randomly throughout the ice core, they clustered in specific annual layers that corresponded to late summer and early fall seasons. This suggested deliberate human activity during the times of year when weather conditions would have made metallurgical work most feasible, periods when fuel could be gathered and accumulated when working outdoors would have been possible, when the products of metalworking could have been put to practical use. The location of the drilling site added another layer of mystery to the discovery. The ice core came from an area that would have been marginally habitable during the warmer periods of the early Holocene, but only for people with sophisticated cold weather survival skills. The site was elevated enough to provide good drainage and clear sight lines, but protected enough to offer shelter from the worst Arctic weather conditions. Attempts to locate the source of the metallic contamination led to ground surveys of the area around the drilling site. These investigations revealed surface features that had and been noticed during the original expedition stone arrangements that showed signs of having been modified by human action. Areas where the natural soil chemistry had been altered in ways that suggested industrial activity. Subtle landscape modifications that spoke of sustained human presence. The stone features showed evidence of having been used for activities that required sustained high heat. Rock surfaces bore the kind of thermal alteration that results from repeated exposure to smelting temperatures. Soil samples from around these features contained elevated levels of the same metallic elements found in the ice core, confirming that the microscopic fragments in the glacier had indeed originated from human activity in the immediate area. Dating of organic materials from the surface sites produced results that aligned closely with the ice core chronology. Charcoal from what appeared to be smelting hearths yielded radiocarbon dates consistent with the period when metallic traces appeared most densely in the glacial samples. The evidence suggested a brief but intensive period of metallurgical activity followed by abandonment that coincided with a documented period of climate cooling. Perhaps most significantly, analysis of the iron fragments revealed techniques that seemed to anticipate later developments in metallurgy by thousands of years. The working methods produced metal with properties that would not be matched by European smiths until the medieval period. This wasn't primitive experimentation with crude techniques, but sophisticated metallurgy that demonstrated deep understanding of the relationships between heat, carbon content, and the properties of finished metal. The implications of Peterson's discovery continue to ripple through the archaeological community. If the evidence is accepted at face value, it suggests that advanced metallurgical knowledge existed in the Arctic thousands of years before such techniques appeared in more temperate regions, where they would have been easier to develop and sustain. The ice that preserved these microscopic traces for 9 millennia continues to yield additional evidence. New analytical techniques reveal organic compounds associated with metallurgical activity, chemical signatures of fuel sources that shouldn't have been available. In the Arctic environment, traces of materials that suggest technological capabilities far beyond what conventional models predict for early Holocene Arctic peoples. As the investigation continues, each new piece of evidence deepens the mystery while making the case for sophisticated early human presence in Greenland increasingly difficult to dismiss. The conference room at the University of Chicago buzzed with the kind of tension that accompanies challenges to established scientific paradigms. Dr. Margaret Thornfield, one of the world's leading experts on Arctic archaeology, stood before a projection showing the latest claims about ancient human presence in Greenland. Her expression carried the weight of decades spent building careful, methodical understanding of how and when humans colonized the Earth's most challenging environments. The problem with these extraordinary claims, Dr. Thornfield began, her voice carrying the authority of someone who had spent 30 years excavating Arctic sites, is that they require us to abandon everything we know about ice sheet chronology, human technological development, and the basic constraints of Arctic survival. The Greenland ice sheet is older than human civilization. The climate data is unambiguous on this point. The mainstream archaeological community has received the growing body of anomalous evidence from Greenland with deep skepticism, and for good scientific reasons. The ice core record, which extends back hundreds of thousands of years, shows that Greenland has been predominantly ice-covered throughout the period when humans developed the technologies necessary for Arctic survival. The brief warm periods that might have allowed habitation were too short and too isolated to support the kind of sustained human presence that would leave archaeological traces. Dr. Erik Johansson, a glaciologist at the Alfred Wegener Institute, adds the perspective of ice physics to the debate. The claims about buried structures beneath the ice sheet ignore fundamental aspects of glacial behavior. He explains, ice moves. It flows. It grinds bedrock into powder and pushes massive boulders hundreds of kilometers from their origin points. Any structures that might have existed would have been destroyed by glacial action long before they could be preserved. The technological arguments carry equal weight. The metallurgical evidence that has emerged from various Greenland sites describes capabilities that took human societies thousands of years to develop in more hospitable environments. The idea that such sophisticated techniques could have been invented and sustained in one of Earth's most challenging environments strains credibility beyond the breaking point. Professor Sarah Chon, whose radar discoveries beneath the ice have been cited as evidence of ancient structures, maintains a position of cautious scientific skepticism about the more dramatic interpretations of her data. We're seeing interesting geological formations, she emphasizes. Natural processes can create remarkably regular patterns. Volcanic activity, sedimentary layering, even the action of ancient water bodies can produce features that superficially resemble human construction. The burden of proof for extraordinary claims must be correspondingly extraordinary, and mainstream archaeology finds the burden has not yet been met. The fragments of worked metal could result from contamination by more recent human activity. The geometric patterns visible in satellite imagery could represent natural geological processes that create misleading appearances of purposeful construction. The oral traditions that speak of ancient inhabitants could preserve cultural memories of encounters with known historical peoples, distorted by generations of retelling. Dr. Thornfield's critique extends to the methodological approaches used by researchers claiming ancient civilizations in Greenland. Science advances through careful accumulation of evidence, peer review, and replication of results. She notes, many of these claims rest on isolated finds that haven't been properly contextualized within the broader archaeological record. Extraordinary conclusions based on minimal evidence don't constitute good science. The climate modeling that forms the foundation of mainstream skepticism has grown increasingly sophisticated over the past decade. Computer simulations that incorporate multiple variables, ocean circulation, atmospheric patterns, solar radiation, volcanic activity, consistently show that Greenland's climate during the periods in question would have been hostile to sustained human habitation. Brief warm intervals were not long enough to allow the development of the complex societies that the artifacts seem to suggest. Yet even within the mainstream scientific community, voices urge caution about dismissing all anomalous evidence too quickly. Dr. Lisa Anderson, an archaeologist who has worked extensively in the Arctic, acknowledges the importance of remaining open to new possibilities while maintaining rigorous scientific standards. The history of archaeology is littered with discoveries that challenged established models, she observes. The key is distinguishing between genuine paradigm shifts and wishful thinking. Contamination problem represents a significant challenge for interpreting evidence from Greenland sites. The island has been visited by humans for more than 1,000 years, and modern industrial activity has introduced materials that can create false signals in archaeological contexts. Distinguishing between ancient and recent human activity requires extremely careful excavation and analysis, techniques that aren't always applied consistently. Mainstream geology offers alternative explanations for many of the features that have been interpreted as evidence of ancient human activity. Periglacial processes, the freeze-thaw cycles that occur in regions adjacent to glaciers, can create geometric patterns in stone arrangements that mimic human construction. Natural weathering of bedrock can produce formations that appear artificial when viewed from certain angles or in particular lighting conditions. The statistical problem looms large in evaluating claims about ancient Greenland civilizations. With hundreds of researchers looking for anomalous evidence across thousands of square kilometers of territory, the discovery of apparently significant patterns may represent nothing more than the inevitable result of extensive searching. Without proper statistical controls and replication of findings, individual discoveries may represent false positives rather than genuine archaeological evidence. As the scientific debate continues, mainstream archaeology maintains its position that extraordinary claims require extraordinary evidence. The ice-covered landscape of Greenland undoubtedly holds many secrets, but separating genuine archaeological discoveries from the products of wishful thinking, contamination, and natural processes requires the kind of careful, methodical investigation that has made archaeology a reliable source of knowledge about the human past. The white expanse of Greenland continues to guard its secrets, challenging both believers and skeptics to bring their best evidence to a debate that may ultimately reshape our understanding of human achievement in Earth as most challenging environments. Deep beneath the North Atlantic's gray waters, sonar pulses reveal landscapes that haven't breathed air for millennia. The seafloor off Greenland's coast tells a story of dramatic transformation, not just the gradual changes that mark geological time, but rapid alterations that speak of climate catastrophe and the drowning of entire worlds beneath rising seas. Marine geologist Dr. Anders Christofferson guides his research vessel through waters that once were land. The multi-beam sonar array mounted beneath the ship's hull sends acoustic signals into the depths, painting detailed pictures of submerged topography on computer screens in the ship's laboratory. What emerges from this underwater mapping resembles the ruins of a drowned continent-terraced coastlines that once supported complex ecosystems, river channels that carved their paths when sea level stood dozens of meters lower than today. The post-glacial flooding happened remarkably quickly, Dr. Christofferson explains as his team processes the latest sonar data. When the ice sheets began their final retreat around 14,000 years ago, sea levels rose at rates that would have been catastrophic for any coastal populations. Entire landscapes disappeared beneath the waves in periods measured in centuries rather than millennia. The submerged terraces tell their story in sediment layers and drowned river systems. These aren't the smooth, gradually sloping continental shelves that characterize most oceanic margins, but complex landscapes of protected bays, elevated headlands, and river deltas, the kind of varied topography that would have provided optimal conditions for human habitation during the Ice Age, when sea levels were dramatically lower than today. Most intriguingly, the sonar mapping has revealed features that don't fit simple models of natural landscape formation. Regular alignments of stones that follow contours too precise to be accidental circular formations that appear at consistent intervals along what would have been ancient shorelines, linear features that suggest the presence of constructed harbors and breakwaters designed to protect coastal settlements from storm damage. The timing of the drowning aligns disturbingly well with cultural disruptions visible in the archaeological record across the North Atlantic region. The Younger Dryas period, with its rapid climate changes and associated sea level fluctuations, coincides with the disappearance of several sophisticated Upper Paleolithic cultures. The rising waters that claimed these coastal landscapes might also have claimed the communities that depended on them. Recent advances in underwater archaeology have allowed direct investigation of some of these submerged features. Remote-operated vehicles equipped with high-resolution cameras and sampling equipment have descended to the drowned coastlines, bringing back evidence that challenges conventional assumptions about what these landscapes could have supported. The sediment cores extracted from the seafloor contain more than just geological information. Buried within the marine deposits are organic materials that speak of terrestrial ecosystems, pollen from plants that require freshwater conditions, remains of land animals that couldn't have survived in marine environments, even traces of charcoal that suggest controlled burning on landscapes that are now dozens of meters underwater. Perhaps most significantly, some cores contain artifacts that appear to be of human manufacture. Stone implements show signs of deliberate shaping and use-wear patterns consistent with tool use. Fragments of worked bone display modifications that suggest purposeful crafting rather than natural processes. These materials appear in stratigraphic contexts that place them on dry land before the post-glacial flooding, suggesting human presence on landscapes that subsequently disappeared beneath the waves. The chemical signatures preserved in marine sediments tell additional stories of human activity. Elevated levels of elements associated with metallurgy appear in layers that date to the period just before major sea level rises. Organic compounds that typically result from agricultural activity show up in sediment cores from areas that would have been fertile coastal plains before the flooding. These chemical fingerprints suggest that the drowned landscapes supported not just human presence, but organized human activities that left traces in the geological record. The distribution of underwater features follows patterns that would have made strategic sense for coastal peoples. Sites cluster around natural harbors that would have provided protection from ocean storms, near the mouths of rivers that would have supplied fresh water and served as transportation corridors in locations that would have offered commanding views of approach routes and good defensive positions. Modern fishing operations occasionally bring up artifacts from these submerged landscapes. Trawling nets drag across the seafloor, sometimes return stone implements, worked bone objects, even fragments of metal that show signs of having been shaped by human hands. While most of these finds lack proper archaeological context, their consistent appearance in specific depth ranges suggests that they originate from coherent archaeological deposits, rather than random scatter. The preservation conditions in marine environments have protected organic materials that would have decomposed long ago on dry land. Wood artifacts retain their original shapes and tool marks. Leather objects preserve evidence of stitching and decorative work. Even textiles sometimes survive in forms that allow analysis of weaving techniques and fiber sources. These preserved materials suggest technological capabilities that exceed what conventional models predict for Ice Age. Populations in the North Atlantic region. Climate models that incorporate both ice sheet dynamics and ocean circulation patterns paint a picture of rapid environmental change during the post-glacial period. The melting of the Laurentide and Fennoscandian ice sheets didn't just raise sea levels gradually. It triggered complex feedback loops that accelerated the process. Coastal communities would have faced not just slowly rising waters, but sudden storm surges, altered current patterns, and changes in marine productivity that would have disrupted traditional subsistence strategies. The drowned coastlines continue to yield their secrets as oceanographic technology advances. Each new survey reveals additional features that challenge simple interpretations each sediment core contains. Organic materials that speak of complex ecosystems. Each accidental discovery by fishing operations adds to the growing inventory of human artifacts from landscapes that now lie beneath the waves. As storm waves break against Greenland's current coastline, they echo with the memory of worlds that vanished beneath rising seas, carrying whispers of communities that may have watched their homelands disappear beneath waters that rose faster than human memory could preserve their stories. From the vantage point of a satellite orbiting 400 kilometers above Earth's surface, patterns emerge from the Arctic landscape that terrestrial observers miss entirely. The high-resolution imagery captured by commercial and scientific satellites reveals something extraordinary across the Arctic regions of North America, Siberia, and most provocatively, Greenland stone alignments that stretch for kilometers across tundra and through valleys, geometric arrangements that speak of purposeful construction rather than random glacial scatter. Dr. Vincent Lamarche, an archaeoastronomer at the Centre National de la Recherche Scientifique in Paris, first noticed these features while analyzing satellite data for an entirely different research project. "I was studying modern caribou migration patterns," he recalls, "when I began seeing linear stone arrangements that followed orientations unrelated to animal movement or natural geological processes. The alignments were too precise, too extensive, and too consistently oriented to be accidental. The megalithic alignments, visible in satellite imagery of Greenland, follow astronomical orientations with startling precision. Stone rows point toward the positions where certain stars would have appeared on the horizon thousands of years ago, accounting for the gradual shift in celestial positions caused by precession of Earth's axis. Other alignments track the extreme positions of the sun during summer and winter solstices, but calculated for periods when the climate would have been significantly different from today. What makes these alignments particularly intriguing is their adaptation to Arctic conditions. Unlike the stone circles and alignments found in temperate regions, which typically track familiar astronomical phenomena, the Arctic arrangements seem designed to navigate the unique challenges of polar observation. They account for the long polar night, the extended twilight periods, and the complex behavior of circumpolar stars that never set below the horizon in far northern latitudes. Ground-based investigation of sites identified through satellite analysis has confirmed the artificial nature of many of these features. The stones aren't randomly distributed glacial erratics, but carefully selected and positioned monuments. Many show signs of having been shaped or modified to improve their visibility and alignment precision. Some sites contain stones that aren't native to the local geology, suggesting transportation from distant sources for specific astronomical purposes. The scale of some alignments defies easy explanation. Linear arrangements stretch for tens of kilometers across the landscape, maintaining precise orientations despite crossing varied terrain. Such extensive constructions would have required coordinated effort by substantial populations working over extended periods. The logistics alone suggest organizational capabilities far beyond what conventional models attribute to small-scale Arctic societies. Carbon dating of organic materials found in association with the megalithic sites has produced consistently ancient dates. Charcoal from hearths built adjacent to stone alignments yields ages ranging from 60 to 12,000 years, placing their construction during periods when Greenland's climate would have been more hospitable than today, but still challenging, enough to make such ambitious projects remarkable achievements. The astronomical orientations encoded in the alignments reveal sophisticated understanding of celestial mechanics. Perhaps most significantly, many of the alignments seem designed to function as integrated networks rather than isolated monuments. Sites positioned on elevated terrain maintain clear sight lines to other sites dozens of kilometers away, suggesting that the megalithic system functioned as a communication network spanning vast territories. Signal fires or other visual markers positioned at aligned sites could have transmitted information across distances that would otherwise have required weeks of travel. The construction techniques evident at the sites demonstrate engineering capabilities adapted to Arctic conditions. Stone foundations extend deep into permafrost to prevent frost heaving that would disturb alignments over time. Drainage systems channel water away from critical structures to prevent ice damage. Some sites incorporate sophisticated understanding of how different materials expand and contract under extreme temperature changes. The distribution pattern of megalithic sites across Greenland follows geographical logic that suggests systematic territorial organization. Sites cluster around areas that would have provided optimal conditions for human habitation during warmer climatic periods. Protected valleys, elevated areas with good drainage, locations with access to marine resources. The spacing between major sites suggests territorial divisions that would have allowed sustainable resource management across large regions. Recent analysis using advanced satellite techniques has revealed additional layers of complexity in the megalithic networks. Infrared imagery shows that many stone alignments incorporate features that aren't visible in ordinary light underground chambers. Buried connecting passages, stone arrangements that create distinctive thermal signatures. These hidden elements suggest that the visible monuments represent only a fraction of the engineering effort that went into creating these sites. The preservation of the megalithic alignments over thousands of years speaks to the skill of their builders. Despite exposure to some of Earth's harshest weather conditions, the alignments maintain their precision with remarkable consistency. The engineering solutions that allow stone structures to survive Arctic conditions while maintaining astronomical accuracy represent technological achievements that shouldn't have been possible for peoples using only simple tools and methods. Most intriguingly, some of the alignments appear to encode information that extends far beyond simple astronomical observation. Mathematical relationships between site positions, stone orientations, and celestial phenomena suggest that the megalithic networks served as repositories of complex information, perhaps scientific knowledge, territorial boundaries, or cultural traditions that required permanent preservation in the landscape itself. As the aurora borealis dances above these ancient stone alignments, it illuminates monuments that may represent one of humanity's earliest attempts to create permanent records of astronomical knowledge, transforming the Arctic landscape into a vast library written in stone and oriented by the stars. In the smoke-filled halls of ancient Ireland, bards recited tales that stretched beyond the boundaries of known geography. Their voices carried stories of Tir na Nog, the land of the young, which lay somewhere beyond the ninth wave, in seas so distant that ordinary ships could never reach them. But these were simple fantasies, woven through the mythological, Narratives were geographical details precise enough to suggest that someone, at some time, had actually voyaged to the places the stories described. The Celtic tradition spoke of islands in the northern sea where time moved differently, where the seasons followed patterns unknown in more southern lands. The Imran texts, the voyage tales that form a distinctive genre in Irish literature, describe lands where the sun never set during summer months, where ice formations created landscapes that seemed like crystal cities, where the very behavior of light and shadow followed laws that seemed magical to people accustomed to more temperate latitudes. Similar stories emerge from the oral traditions of peoples separated by vast distances and centuries of time. The Norse sagas preserved memories of Alfheim, the realm of the light elves, which lay far to the north in regions where aurora phenomena painted the sky in impossible colors. Siberian shamanic traditions speak of an ancestral homeland beyond the ice, where their forebears lived before the great cold forced them south into the forests and steppes. Perhaps most intriguingly, the Sami people of northern Scandinavia preserve oral traditions that describe a homeland called Sapmi that once extended far beyond its current boundaries, reaching into Arctic regions that are now permanently ice-covered. Their stories describe a time when reindeer could migrate to lands that no longer exist, when the people followed hunting routes that led to territories now beneath the ice. The consistency of these mythological themes across disparate cultures suggests something more than simple coincidence. Again and again, the northern paradise is described as a land that was lost to cold not gradually, but suddenly, as if winter arrived like a conquering army and drove the inhabitants south. The survivors of this catastrophe become culture bearers in the myths, bringing knowledge of astronomy, metallurgy, and stoneworking to peoples who had previously known only simpler technologies. Dr. Maria Korhonen, a Finnish folklorist who has spent decades collecting and analyzing Arctic myths, notes the remarkable specificity of many traditional accounts. These aren't vague fantasies about magical lands, she explains. They contain precise descriptions of Arctic phenomena, the behavior of ice, the patterns of animal migration, the way light behaves at extreme latitudes. Someone who told these stories had intimate knowledge of Arctic conditions. The mythological accounts often include details that align remarkably well with modern understanding of past climate conditions. Stories that describe the northern homeland as a place of forests and flowing rivers correspond to periods when paleoclimatic evidence suggests Greenland and other Arctic regions experienced relatively temperate conditions. The timing of the great cooling described in myths aligns with documented climate events like the Younger Dryas. Most significantly, many myths preserve what appear to be accurate memories of astronomical conditions that existed thousands of years ago. Stories that describe the different behavior of stars and the altered paths of the sun and moon in the northern homeland correspond to the gradual changes in Earth's relationship to celestial bodies caused by precession and other long-term astronomical cycles. The technological knowledge attributed to the people of the lost northern lands appears consistently across different mythological traditions. They are described as masters of metalworking, builders of stone monuments, navigators who could read the stars with precision that allowed them to traverse vast distances across trackless seas. These aren't the simple skills of primitive peoples, but sophisticated technologies that took human societies thousands of years to develop. The genetic evidence adds another layer to the mythological puzzle. Modern DNA analysis of northern European populations shows signs of ancient bottlenecking events that correspond roughly to the timing of the mythological catastrophes. Populations that claim descent from the survivors of the northern homeland show genetic markers that suggest their ancestors indeed experienced severe population reductions during the periods when the myths say the homeland was lost. Archaeological discoveries in the Arctic regions have begun to provide physical confirmation for some elements of the mythological record. Stone monuments that align with astronomical phenomena described in myths artifacts that demonstrate technological capabilities attributed to the lost civilizations, evidence of human presence in regions and time periods that correspond to the mythological accounts. The oral traditions also preserve geographical information that has proven accurate in surprising ways. Traditional accounts of travel routes to the northern homeland describe navigation, techniques, and landmark references that correspond to real geographical features, though often in regions that are now ice-covered or submerged beneath rising seas. Perhaps most intriguingly, some mythological traditions seem to preserve information about the aftermath of the northern catastrophe. Stories describe the establishment of new settlements by refugees from the lost homeland, the adaptation of northern technologies to different environments, the gradual development of new cultural traditions that combined elements from the abandoned homeland with innovations necessary for survival in different climates. The persistence of these myths across thousands of years of cultural transmission suggests that they carried information considered too important to lose. In societies without written language, oral traditions served as the primary means of preserving critical knowledge. The survival of consistent mythological themes across multiple cultures implies that the stories encoded information that communities considered essential for their cultural identity and survival. Modern scholarly analysis of mythological traditions has developed techniques for distinguishing between purely symbolic elements and potential historical memories preserved in narrative form. The northern homeland myths contain elements that suggest they preserve genuine cultural memories of real places and events, transformed by generations of retelling, but retaining core information about geographical and climatic conditions that once existed. As the northern lights ripple across Greenland's night sky, they illuminate a landscape that may indeed be the physical reality behind humanity as most persistent myths of lost paradise, the homeland that exists in cultural memory as a place where human civilization achieved remarkable heights before catastrophe forced the survivors to begin again in less hospitable lands. 3 kilometers beneath Greenland's ice sheet, something massive disrupts the planet's magnetic field. The anomaly stretches across an area larger than Manhattan, creating distortions in compass readings that extend far beyond the ice sheet's boundaries. Satellite measurements of Earth's magnetic field reveal the signature of this buried massa A, concentration of ferromagnetic material so extensive that it registers on global magnetic field maps as a distinct feature. Dr. Catherine Morrison, a geophysicist at the Lamont Doherty Earth Observatory, first identified the anomaly while analyzing data from NASA's magnetic field mission satellites. Initially, we assumed we were looking at an unusual geological formation, she explains. Greenland's bedrock contains significant iron deposits, and we expected to find magnetic variations associated with natural mineral concentrations. But this anomaly was different, too concentrated, too geometrically regular, and positioned in ways that don't match typical geological processes. The magnetic signature suggests not just the presence of iron-rich material, but material that has been altered by intense heat. The patterns visible in magnetic field measurements resemble those created by smelting and metalworking activities, but on a scale that dwarfs anything in the historical record. If the readings are interpreted literally, the buried mass contains worked metal in quantities that would require mining and processing, operations extending over centuries. Ground-penetrating radar surveys conducted over the magnetic anomaly have revealed structural features that compound the mystery. Rather than the random distribution of metallic material that would result from natural geological processes, the buried mass shows signs of organization, regular patterns that suggest purposeful arrangement, geometric relationships that speak of design rather than accident. The depth of the anomaly, buried beneath kilometers of accumulated ice, places it in temporal periods when conventional archaeology recognizes no human presence in Greenland. Yet the magnetic signatures are too distinct, too precisely organized, to result from natural processes alone. The material appears to have been concentrated and arranged by forces that understood both metallurgy, and large-scale construction techniques. Recent developments in magnetic field analysis have revealed additional complexity in the buried anomaly. The ferromagnetic signatures aren't uniform throughout the mass, but show variations that suggest different types of metallic materials arranged in specific patterns. Some areas show the signature of pure iron. Others suggest bronze or copper alloys. Still others display magnetic characteristics that don't match any known natural or artificial materials. The geological context of the anomaly raises additional questions about its origin. The surrounding bedrock shows no evidence of the kind of mineralization that would naturally produce such concentrated ferromagnetic materials. The magnetic mass appears to be an isolated feature, unconnected to the broader geological structures of Greenland's subsurface. This isolation suggests that the metallic concentration represents imported material rather than local geological formation. Temperature analysis of the magnetic signatures reveals that the buried materials retain heat signatures that are inconsistent with passive geological cooling. Deep beneath the ice, the metallic mass maintains temperature characteristics that suggest either ongoing chemical processes or thermal properties that result from artificial rather than natural formation. The heat patterns follow the same geometric organization visible in the magnetic field measurements. The positioning of the anomaly beneath Greenland's ice sheet creates practical challenges for direct investigation. The depth of burial makes conventional archaeological excavation impossible, while the overlying ice mass prevents most forms of remote sensing from providing detailed information about the buried materials. Researchers must rely on indirect measurements that reveal the anomaly's existence without explaining its true nature. Comparative analysis with known geological formations worldwide has failed to identify natural processes that could create similar magnetic signatures. The concentration of ferromagnetic material, the geometric organization of the mass, and the thermal characteristics all point toward artificial origin. Yet the scale and depth of burial suggest capabilities far beyond anything attributed to historical human societies. The discovery of the magnetic anomaly has prompted searches for similar features elsewhere in Greenland and other Arctic regions. Preliminary surveys have identified several smaller magnetic concentrations that show similar characteristics: organized metallic masses buried beneath ice or permafrost, positioned in locations that would have been more accessible during periods of different climate conditions. The timing of the anomaly's burial, inferred from ice core chronology and geological dating of the surrounding materials, corresponds to periods of dramatic climate change in the Arctic. The metallic mass appears to have been covered by advancing ice during the same climatic periods that saw the abandonment of known human settlements in Greenland and other northern regions. Perhaps most intriguingly, the magnetic anomaly shows signs of being connected to surface features through what appear to be artificial channels or passages. Magnetic field measurements suggest that metallic materials extend upward from the main mass through formations that follow geometric patterns rather than natural geological structures. These connecting features terminate at depths that would have been accessible from the surface during periods when ice cover was less extensive. The implications of the magnetic anomaly extend beyond simple questions of archaeological chronology. If the buried mass indeed represents artificial construction, it suggests technological capabilities and organizational achievements that challenge fundamental assumptions about human development in Arctic environments. The scale of metalworking implied by the magnetic signatures would require knowledge, resources, and sustained effort that conventional models consider impossible for pre-industrial Arctic societies. As researchers continue to analyze the magnetic data and develop new techniques for investigating features buried beneath Greenland, ice, the anomaly remains one of the most compelling pieces of evidence for advanced human presence in the Arctic during periods conventionally considered prehistoric. The metallic mass waits in the darkness beneath the ice, its magnetic field reaching toward the surface like a signal from a civilization that history has forgotten. The ice acts as Earth's most faithful archivist, preserving in crystalline detail the atmospheric conditions, biological communities, and chemical signatures of ages long past. As Greenland's glaciers retreat under the pressure of modern warming, they release their archives organic materials, microscopic organisms, and chemical compounds that have remained frozen in time for millennia, emerging now like messages from vanished worlds. Dr. Sarah Chun, a molecular biologist at the University of Alaska Fairbanks, leads one of the most ambitious attempts to read these frozen libraries. Her laboratory processes samples from retreating ice margins, using advanced DNA sequencing techniques to identify organisms that last lived when mammoths roamed the Arctic and the global climate system followed patterns that no human society had ever experienced. Every ice sample is a time machine, Dr. Chun explains as she examines slides containing microscopic organisms that have been dormant for thousands of years. The ice preserves not just individual species, but entire ecosystems. We're finding bacteria, fungi, plant material, even fragments of insect exoskeletons, the complete biological signatures of environments that disappeared when the ice advanced. But the biological discoveries represent only the beginning of what the retreating ice reveals. Chemical analysis of meltwater from ancient ice layers shows signatures that don't match purely natural ecosystems. Elevated levels of elements associated with metallurgy appear in ice that melted from layers dating to periods when no known human activity occurred in the region. Organic compounds that typically result from controlled burning, agriculture, and industrial processes emerge from ice formations that froze thousands of years before such activities were thought possible in the Arctic. The preservation conditions in glacial ice exceed anything achievable through human technology. DNA remains intact for periods that would see it degrade completely in other environments. Protein structures maintain their original configurations. Even complex organic molecules that break down rapidly under normal conditions survive in perfect condition within the crystalline matrix of ancient ice. Recent discoveries have yielded organic materials that challenge conventional understanding of what the ice could preserve. Fragments of worked leather emerge from ice layers, showing stitching patterns and tool marks that speak of sophisticated manufacturing techniques. Textile fibers appear in concentrations too high to result from long-distance wind transport, suggesting local production of cloth materials during periods when the surrounding landscape was supposedly uninhabitable. Perhaps most remarkably, the ice has preserved microscopic traces of human presence that would be impossible to detect through conventional archaeological methods. Skin cells, hair fragments, even traces of breath contain DNA that can be analyzed to determine the genetic characteristics of people who lived near the ice thousands of years ago. These biological signatures appear in ice layers that predate known human presence in Greenland by substantial margins. The chemical signatures preserved in ancient ice tell stories of technological sophistication that seem impossible for their time periods. Compounds associated with soap making appear in ice layers from the early Holocene. Traces of dyes and pigments suggest artistic activities that required knowledge of complex chemical processes. Even evidence of fermentation appears in ice samples, indicating food preservation techniques that required controlled environmental conditions. The ice cores also preserve evidence of catastrophic events that left their signatures in the atmospheric record. Layers containing unusual concentrations of metal particles, glass spherules, and shocked minerals correspond to periods of major climate disruption. These signatures align with mythological traditions that describe cosmic catastrophes and the sudden transformation of habitable lands into frozen wastelands. Microscopic analysis of ice samples has revealed worked materials that shouldn't exist in these temporal contexts. Fragments of metal that show signs of having been shaped by tools more advanced than anything attributed to early Arctic peoples. Stone particles that bear the microscopic scars of having been worked with metal implements. Even traces of glass that show signs of having been deliberately manufactured rather than formed by natural processes. The biological diversity preserved in the ice exceeds what modern Arctic ecosystems support. Species lists extracted from ancient ice layers include plants and animals that haven't been seen in Greenland for thousands of years, suggesting that past climatic conditions supported far more complex biological communities than the current environment maintains. Some species identified from the ice archives have no modern analogs, representing evolutionary lineages that disappeared during the climatic transitions that created current Arctic conditions. The temporal distribution of human-associated materials in the ice archives follows patterns that correlate with documented climate variations. Periods of increased chemical signatures associated with human activity correspond to times when paleoclimatic evidence suggests more hospitable conditions in Greenland. As signatures diminish or disappear during periods of documented climate deterioration, suggesting that human presence in the region was closely tied to environmental conditions. Recent advances in analytical chemistry have revealed even more sophisticated signatures preserved in the ice. Compounds associated with pharmaceutical preparation appear in samples from periods when such knowledge was supposedly unknown to human societies. Chemical signatures of controlled fermentation processes suggest brewing or food preservation techniques that require detailed understanding of biological processes. The isotopic signatures of organic materials from the ice archives provide information about the diets and environmental conditions experienced by the organisms that contributed them. Analysis of ancient plant material reveals growing conditions that correspond to climates significantly warmer and more stable than Greenland experiences today. Animal remains show isotopic signatures indicating diets that included plants and prey species that no longer exist in Arctic environments. As each season brings new melting and new revelations from the ice archives, the picture of past Arctic life grows increasingly complex. The ice that once seemed like a barrier to understanding past environments has revealed itself as the most complete record available of what life, including human life, accomplished in one of Earth's most challenging environments during periods when that challenge was somewhat less formidable than it appears today. The secrets held in Greenland ice continue to emerge as modern warming reverses processes that have preserved them for millennia, each sample offering glimpses of worlds that existed before the current patterns of ice and cold established their dominion over the Arctic landscape. The hunters first noticed the discoloration on a calm morning in March 2024, when unusual atmospheric conditions had settled over the Scoresby Sound region of eastern Greenland. Instead of the pristine white that normally blanketed the landscape after a night of snowfall, patches of dark material spotted the fresh snow like inkblots against paper. The Inuit hunters, whose survival depended on reading every nuance of Arctic weather patterns, recognized immediately that something unprecedented was occurring. Malik Powelson, a traditional hunter whose family had lived in the region for 7 generations, first alerted authorities to the phenomenon. This was not normal snow, he reported to researchers at the Danish Meteorological Institute. It felt like snow when it hit your face, but it carried something dark within it. The old people in my community had never seen anything like this. Initial analysis by atmospheric scientists suggested the obvious explanations: volcanic ash from a distant eruption, industrial pollution carried by unusual wind patterns, perhaps dust from exposed soil as permafrost melted in other regions. But laboratory examination of the black snow samples revealed something far more mysterious than any of these conventional sources could explain. Dr. Jesper Andersen, an atmospheric chemist at the University of Copenhagen, processed the first samples sent from Scoresby Sound. Under microscopic examination, the dark material proved to be a complex mixture of carbon particles, metallic fragments, and organic compounds that didn't match any known contemporary sources. The carbon showed signs of having been produced by very high temperature combustion, Dr. Andersen reported. The metallic particles included alloys that aren't used in modern industry. The organic compounds suggested plant material that had been subjected to extreme heat. Carbon dating of the organic components produced results that seemed impossible. The plant material embedded in the black snow yielded radiocarbon ages of approximately 9,000 years, placing its origin in the early Holocene period, when Greenland's climate was significantly different from today. Yet this ancient material was falling from contemporary skies, mixed with modern atmospheric moisture to create the anomalous precipitation. The geographical distribution of the black snow provided additional clues about its origin. Rather than falling uniformly across the region, the discolored precipitation concentrated in specific areas that corresponded to locations where unusual geological features had been identified through satellite imagery. The heaviest concentrations occurred over sites where ground-penetrating radar had detected buried structures beneath the permafrost. Chemical analysis revealed that the metallic particles in the black snow contained elements in proportions that suggested artificial rather than natural origin. Iron fragments showed signs of having been worked at temperatures that exceeded anything achievable through natural processes. Copper particles contained trace elements that indicated deliberate alloying. Even stranger were fragments of materials that didn't correspond to any known metallurgical traditions. The atmospheric conditions that produced the black snow were themselves unusual. Weather station data showed temperature inversions and wind patterns that created localized atmospheric disturbances directly above the areas where the discolored snow fell most heavily. These meteorological anomalies suggested that whatever was producing the dark material was generating enough heat to alter local weather patterns. Subsequent investigation revealed that the black snow phenomenon wasn't entirely unprecedented. Archival research uncovered scattered reports of similar events from the same region dating back more than a century. Inuit oral tradition preserved accounts of dark snow that fell during specific weather conditions, usually associated with unusual warming periods that caused accelerated melting of permafrost and glacial ice. The connection between atmospheric warming and the appearance of black snow suggested that the dark material was being released from sources buried beneath Greenland's frozen ground. As permafrost melted and glacial ice retreated, materials that had been locked in frozen storage for millennia were being liberated and carried into the atmosphere by thermal updrafts and sublimation processes. Ground investigations at sites where black snow concentrations were highest revealed surface features that had been noticed during previous surveys. Areas of discolored soil where the snow had melted showed chemical signatures that matched the atmospheric samples. Excavation at these sites uncovered layers of carbonized material, metallic fragments, and organic remains that appeared to be the source of the atmospheric contamination. The stratigraphy at the excavation sites told a story of ancient catastrophe. Layers of ash and charcoal suggested extensive burning, but the temperatures required to produce the observed chemical signatures exceeded anything that natural wildfires could achieve. The metallic fragments were distributed through soil layers in patterns that suggested they had been deposited during the same high-temperature events that created the carbonized materials. Perhaps most significantly, the organic materials preserved in the soil layers included plant species that hadn't grown in Greenland for thousands of years. These weren't just random plant remains, but materials that showed signs of having been deliberately collected and stored seeds, processed fibers, even fragments of worked wood that suggested sophisticated carpentry techniques. The black snow continued to fall intermittently throughout the 2024 season, each occurrence releasing additional ancient materials into the modern atmosphere. Analysis of successive samples showed that the phenomenon was progressively accessing deeper and older buried materials, as if the source deposits were being systematically exposed by ongoing environmental changes. The implications of the black snow discoveries continue to reverberate through the archaeological and climatological communities. The phenomenon suggests that Greenland's permafrost and glacial ice preserve materials from human activities that occurred thousands of years before such activities were thought possible in the Arctic. As climate change continues to alter the conditions that have preserved these materials for millennia, more evidence of sophisticated ancient Arctic cultures may literally fall from the sky. The dark particles continue their ancient journey from buried sources to contemporary skies, carrying with them chemical signatures of technologies and societies that history had forgotten, now returning to the surface world as messengers from a frozen past. Night falls slowly over Greenland's interior, the summer sun reluctant to abandon its watch over the endless ice. But when darkness finally claims the landscape, it brings with it a silence so complete that it seems to possess weight and substance. This is not merely the absence of sound, it is presence itself, the accumulated quiet of millions of years pressed into crystalline form and spread across 2 million square kilometers of frozen time. Standing on the ice sheet's vast expanse, surrounded by horizons that curve with the planet itself, one becomes acutely aware of the profound solitude that has defined this place for most of its existence. The wind moves without sound across surfaces too smooth to catch and hold its voice. Footsteps disappear immediately into snow that has never heard human passage before. Even one's own breathing seems intrusive in this cathedral of silence. Yet as the hours pass and eyes adjust to the Arctic night, the ice begins to reveal its secrets. The aurora borealis emerges like celestial fire, painting the dome of sky in colors that have no names in temperate languages. Green curtains of light ripple across the stars, sometimes joined by ribbons of pink and purple that dance to rhythms older than human music. These displays aren't mere atmospheric phenomena. They are the visible breath of a planet communicating with the cosmos, magnetic field lines made manifest in spectral beauty. Beneath this cosmic display, the ice sheet stretches toward every horizon, its surface broken only by subtle undulations that hint at the buried landscape below. From this elevated perspective, it becomes possible to imagine the world that lies sleeping beneath miles of accumulated snow and ice. Valleys where rivers once flowed, mountains that once stood proud against the sky, coastlines where waves once lapped against shores that knew the sound of running water and the rustle of vegetation in Arctic wind. The ice preserves more than just landscape, it holds entire epochs in suspension. Every layer represents a year of Earth's history. Every bubble contains air from ancient atmospheres. Every particle of dust carries information about volcanic eruptions, meteor impacts, and climate variations that occurred when this land knew different seasons. To stand on this ice is to stand atop the planet's most complete library, its contents written in crystal and accessible only to those who understand the language of frozen time. In the deep silence, imagination begins to populate the hidden landscape with the peoples who might once have called it home. Communities that learned to read the subtle signs of Arctic weather, families that gathered around fires whose smoke has long since dispersed into ancient atmospheres, builders who left their mark in stone foundations, now buried beneath the accumulated weight of centuries of snowfall. The archaeological evidence suggests they were here, the radar signatures of buried structures, the chemical traces in ice cores, the oral traditions that preserve their memory in myth and legend. But standing on the ice in the profound quiet of Arctic night, their presence becomes something more than academic speculation. It becomes possible to sense the echo of human voices, carried in wind that has blown across this ice for thousands of years. The stars wheel overhead in patterns that would have been familiar to those ancient inhabitants, though their positions have shifted slightly due to the slow wobble of Earth's axis. The North Star, around which the entire celestial sphere appears to rotate, hangs in space like a fixed point of reference for navigation and timekeeping systems that might have been more sophisticated than conventional. Archaeology acknowledges. Beneath the starlight, the ice reveals subtle variations in texture and color that speak of the dynamic processes hidden beneath its seemingly static surface. Ice flows toward the margins of the continent, carrying with it materials that have been locked in frozen storage for millennia. As it moves, it brings ancient atmospheres, biological remains, and possibly artifacts from buried human settlements toward the edges where warming temperatures are beginning to release them back into the modern world. The silence itself becomes a form of communication, a temporal bridge that connects the present moment with all the quiet moments that have preceded it across thousands of years of Arctic night. In this profound stillness, time seems to lose its linear quality, past and present blending into a single eternal moment where the ancient and the vast contemporary coexist in the crystalline matrix of ice and memory. The aurora continues its eternal dance overhead, sometimes reaching toward the ice with streamers of light that seem to touch the surface before retreating back into the upper atmosphere. These displays have illuminated Greenland's ice for as long as the planet has possessed a magnetic field, providing light for any peoples who might have lived here during the long polar night, marking the passage of seasons and serving as celestial calendar for communities that needed to track times as a passage with precision necessary for survival. As the night deepens and the aurora fades toward dawn, the silence reasserts itself with even greater intensity. But now it carries within it all the sounds that have ever broken this quiet, the voices of peoples whose names are forgotten, the ring of metal tools against stone, the songs that celebrated survival through another Arctic winter, the stories that preserved knowledge and memory across generations that lived at the edge of the possible. The ice keeps all these secrets, holding them in suspension until the day when warming temperatures or advancing technology finally unlocks the archives that lie beneath this white silence. Until that day, the ice sheet continues its patient vigil, guardian of mysteries that wait in frozen darkness for the world to remember their stories.